This is Ajitha, working as Assistant Professor, Institute of Aeronautical Engineering, Dundigal. Today, we are going to see the power relations of single tone and the multi-tone AM wave. So before that, we know the modulation. So modulation is the term in communication, very important term in communication. It requires two signals, message signal M of t and the carrier signal C of t. So this modulation, we can treat carrier as a envelope when we send a post or courier. So we'll keep the information inside the envelope. So the carrier acts as a envelope in modulation. So we should not use for carrier no more after retrieving the message signal at the receiver. So this acts like a envelope. So M of t is the message signal. So modulation is classified into amplitude modulation and angle modulation. So we are in amplitude modulation part, amplitude modulation and angle modulation. In amplitude modulation, amplitude of the message, so this is the message signal represented in time domain as M of t, and this is the message signal represented in frequency domain. As we know, we are going to analyze the signals both in time domain and frequency domain. This is message signal in time domain M of t. This is the arbitrary shaped waveform. So we can represent message as M of t and its spectrum as M of f. So this is the shape of the M of f. So this message in time domain is converted into frequency domain by using Fourier transform. This is the message signal. And carrier signal we are going to take as sinusoidal signal or cos signal. This can be represented mathematically as AC cos 2 pi FCT. AC cos 2 pi FCT. So after applying the Fourier transform for the carrier signal, this is impulse at frequency FC and frequency at minus FC. So due to the symmetry, so there exists for each positive frequency, there exists a negative frequency minus FC because we are using Fourier transform for the conversion from time to frequency, and the magnitude of the impulse is AC by 2 at the frequency FC. So carrier signal in time domain and carrier signal in frequency domain. So definition of the amplitude modulation, amplitude of the message carrier signal varies in accordance with the message signal. So this is the amplitude of the carrier signal is going to vary in accordance with the information signal or message signal. So amplitude of the carrier is going to vary in accordance with the message signal. This is the AM wave in time domain and the AM wave in frequency domain. So after modulation, this is the spectrum of message signal. It is going to shift to carrier frequency. So message signal originally present at the lower frequency from 0 to W, it contains the information, but after modulation, it shifts to carrier frequency. Actually, we can write the amplitude wave, amplitude modulation equation as in time domain, we can write the equation AC into, so S of t is the equation of the AM wave. It can be represented as AC into, so its frequency is cos 2 pi FCT only. It is not going to change, but according to carrier amplitude is going to vary by with respect to message signal. So this is called the envelope of the AM wave. This is called the envelope of the AM wave. AC into 1 plus Ka into M of t into cos 2 pi FCT. So this is the equation of the AM wave for general M of t as any information. Message signal as M of t. But single tone modulation means single tone, the name itself, it contains one frequency in message signal. So we'll treat it as M of t as a sinusoidal signal or cos signal. It contains only one frequency, AM cos 2 pi FMT. If we consider m of t as am cos 2 pi fmt, then it is called as single tone amplitude modulation. Single tone means it contains only one frequency, fm. So if we replace in the equation, in the am equation, AC into 1 plus Ka into m of t as am cos 2 pi fmt. Am cos 2 pi fmt multiplied with cos 2 pi fct. So this is the equation for single tone AM, and we will assume this Ka into AM as the term mu. Mu is called the modulation index of the AM wave. So now the equation will become AC into 1 plus mu cos 2 pi fmt multiplied with cos 2 pi fct. This is the equation of single tone AM wave. AC into 1 plus mu cos 2 pi fmt multiplied with cos 2 pi fct. This is the equation of AM wave. If you expand this term, first term is AC cos 2 pi fct and the second term is mu AC multiplied with cos 2 pi fmt multiplied with cos 2 pi fct. First term is again a carrier term. Second term contains the product of two cos terms, cos 2 pi fmt multiplied with cos 2 pi fct. So we are going to get here AC cos 2 pi fct as the first term, and we know the cos A cos B formula. Cos A cos B formula in trigonometric, cos A plus B plus cos A minus B. Cos A plus B plus cos A minus B. We have 2 cos A cos B. So we don't have 2 cos A cos B. So we are going to multiply and divide with the 2. And A is here 2 pi fmt and B is here 2 pi fct. So we are going to get the A plus B term as cos 2 pi into fc plus fm into t plus mu AC by 2 into cos 2 pi into fc minus fm into t. So this is the equation of single tone AM wave. AC cos 2 pi fct, the term is called the carrier term. Mu AC by 2 into cos of 2 pi into fc plus fm into t. So this is higher than the carrier frequency. So this term we will call it as USB, upper sideband term. And fc minus fm is lower value than carrier frequency. So this term is called as lower sideband. So AM wave contains the carrier term and upper sideband term and lower sideband term. So amplitude of the carrier is AC. Amplitude of the upper sideband is mu AC by 2. Amplitude of the lower sideband is mu AC by 2. So this is the time domain equation for single tone AM wave. Coming to this is a single tone. As I told, message signal is a cos or sine signal which contains some frequency FM, and carrier wave carrier wave is also cos or sine, and AM wave is less than 1. We can call it as under modulation. Mu value, mu is called the modulation index of AM wave. This mu is defined as Ka into AM, or it is equivalent to AM by AC. It is the ratio of amplitude of the message signal to amplitude of the carrier signal. Mu less than 1, mu value equal to 1, mu greater than 1. The modulation is classified into under modulation, 100% modulation and over modulation. Coming to the spectrum, as we know this is also cos signal. So spectrum is AM by 2 with amplitude impulse at FM and minus FM. So frequency of the signal is FM. So at the FM we are going to get an impulse. That is the Fourier transform of cos signal. Similarly, carrier is also cos. It is also contains impulse at frequency FC and minus FC with an amplitude of AC by 2 and AC by 2. Then after modulation we have carrier term is there, that is AC by 2, and this is the carrier term at AC by 2. After carrier FC to FC plus FM. FC plus FM term is known as USB term, upper sideband. What is the upper sideband magnitude? Mu AC by 2 in time domain. But frequency domain, its amplitude become mu AC by 4. Similarly, FC minus FM is called the lower sideband term. Magnitude is mu AC by 2, but in frequency domain it will become one more 1 by 2 will come, that is mu AC by 4. This is a single tone modulation in time domain and frequency domain. When we want to calculate the power required for AM wave, so time domain, it consists of 3 terms. Carrier term is there, upper sideband term is there, and lower sideband term is there. Let us see the power relations in AM wave. So this is the equation of AM wave. This is the carrier amplitude, and this is the upper sideband amplitude, and this is the lower sideband amplitude. So in the calculation of power, as we know, for AC signal, we are going to take the RMS value, root mean square value of the peak signal, root mean square value of the sinusoidal signal divided by load resistance. We know V square by R as the power. But here we can take it as RMS value, root mean square value. So total power equal to carrier power plus upper sideband power plus lower sideband power. Because it contains 3 terms. This is the carrier term, and the second term, this is called upper sideband term, and this is called lower sideband LSB term. So the power is also total power equal to carrier power plus upper sideband power plus lower sideband power. So before calculation of power, we need to consider RMS value. What is the RMS value? How can we calculate this RMS value? So RMS value equal to peak voltage divided by root 2. Peak voltage divided by root 2. So peak voltage in the first term is AC, and the second term is mu AC by 2 is the total peak voltage, and third term is also mu AC by 2. So peak voltage divided by root 2. So first term carrier power, in the calculation of carrier, peak voltage is AC. AC cos 2 pi FCD. This is the carrier term. So peak voltage is AC. So by root 2. AC by root 2 whole square by R. So this AC square by 2R is called the carrier power. And upper sideband power. What is upper sideband term? Mu AC by 2 cos 2 pi into FC plus FM into T. This is the upper sideband term in time domain. So power calculations are done in time domain only. So we need to consider the time domain equation in the calculation of power. So mu AC by 2 is the peak voltage. Peak voltage by root 2. So mu AC by root 2. Peak voltage by root 2 whole V square by R. So this will become mu square AC square. 2 square is 4. Root 2 whole square is 2. So this will become mu square AC square by 8R. Similarly, the lower sideband term is mu AC by 2 into cos 2 pi into FC minus FM into T. This is the lower sideband term. So peak value by root 2 becomes RMS value. So RMS square value is mu AC by, we should consider peak value by root 2, V square by R. Again, this calculation will become AC square mu square by 8R. This is the power required in lower transmission of the lower sideband. So if we add all the powers, total power equal to carrier power is AC square by 2R, upper sideband power is AC square mu square by 8R, and the lower sideband power is AC square mu square by 8R. If we take the common AC square by 2R as the common, first term is 1 is common, and second term we have mu square by 4, and third term we have mu square by 4. If we simplify again, PT equal to AC square by 2R into 1 plus this mu square by 4 and mu square by 4, it is going to get mu square by 2. So we know AC square by 2R as the carrier power. So PT equal to PC into 1 plus mu square by 2. This is the total power. Pt equal to Pc into 1 plus mu square by 2. From this expression, we are going to conclude some conclusions here. If we see here, if we expand Pt equal to Pc into 1 plus mu square by 2. So Pc plus Pc into mu square by 2. Expand this term. So first term is called the carrier power. And the second term is called, this is completely sideband power. Pc into mu square by 2 is called a sideband power. That is for two sidebands, upper sideband and lower sideband. If we consider only one sideband, so USB power is Pc into mu square by 4. Similarly, if we consider lower sideband term, it is Pc into mu square by 4. This is the upper sideband power and this is the lower sideband power. Then after, what is the efficiency of AM wave? As we know, information is contained only among the three terms. Information is contained in this Fc plus Fm. It contains the Fm term because we need ultimately message signal. So upper sideband contains the message signal term and the lower sideband is also contains the message term. So but there is no message term in the first term. So unnecessarily we are transmitting the carrier signal for AM wave. So we have a term called transmission efficiency. The term is called the transmission efficiency. What is the transmission efficiency of AM wave is? It is the ratio of transmitted power which contains the information. So as we know, the information is contained in two terms only. The two terms are upper sideband term and lower sideband term. These two terms contains the information. So efficiency indicates the ratio of information contains power divided by total power. So information contained is upper sideband plus lower sideband and total power is Pc into 1 plus mu square by 2. If we simplify this one, as we know, the sideband power is Pc into mu square by 2 and the total power is Pc into 1 plus mu square by 2. This indicates the useful power in the total power. So how much power is useful in the transmission of AM wave for sending the information. So Pc into 1 plus mu square by 2 is the total power of the AM wave. And this one, Pc into mu square by 2 is the sideband power. So transmission efficiency is, it is a ratio of sideband power to the total power. Sideband power to the total power. If you simplify this equation, Pc gets cancel each other and the efficiency is going to get mu square by 2 plus mu square into 100%. We will denote this transmission efficiency in terms of percentages. So eta formula is, efficiency formula is mu square by 2 plus mu square into 100%. Based on the mu value, so how much power is in sidebands and how much power is in carrier wave. So maximum transmission efficiency of AM signal is, it is going to provide efficiency of AM signal at 33.33%. When mu value equal to 1, what happens? Efficiency mu square by 2 plus mu square, that is 1 by 3 into 100%. 1 by 3 into 100%. 1 by 3 into 100% is 33%. So modulation index 1 value, we know the modulation index maximum value 0 less than mu less than or equal to 1. Mu greater than 1, it is called over modulation. So we cannot use over modulation for the transmission purpose. So maximum value of mu value is 1. So what is the maximum power efficiency is? It is going 33% only. 33.3% means 33.3% only carries sideband information. 33.3% only sideband power. Remaining 66.6% of power is wasting in the transmission of the carrier signal. So we can say that AM is highly inefficient method of analog modulation, amplitude modulation, because 66% of power is wasted in the carrier power. Only 33% is useful in the sidebands, and 66% of power is going to waste for the unnecessary transmission of the carrier signal. So this is the graph when modulation index is going to increase. So modulation index 0, 0.5, 1, 1.5. So what is happening here is AM power by carrier power. AM power by carrier power, it is going on increasing. So that means the power wastage is going on increasing. And this is one more graph which indicates, suppose mu value is 1, mu value 0.25. What is its efficiency? Eta. So we can use the formula mu square by 2 plus mu square into 100% for the calculation of transmission efficiency. Suppose mu value 0.5, it will become 0.25 square by 2 plus 0.25 square into 100%. So this indicates mu 0.25, 0.03. If we multiply with 100, we are going to get the 3% only sideband power, 3% only sideband power, and 97% is wasted in the carrier power. If you take mu equal to 0.5, we are going to get the efficiency value 0.11. 0.11 means 11% is only sideband power. Remaining 89% is wasted in the carrier power. Similarly, mu 0.75, 22% is only sideband power. Remaining 78% is wasted in the carrier power. Similarly, mu value 1, 33% sideband power, and remaining 66% is wasted in the carrier power. So this graph indicates when the modulation index is going on increasing, sideband power is going to increase and the carrier power is going to decrease. So mu value 0.5, we are having 11% of sideband frequency but 89% of carrier. When sideband power increases, carrier power is going to decrease. This is the meaning of that graph. For mu equal to 0.5, only 11% is only useful. Mu equal to 1, 33% only sideband power. On what is voltage and current relations of AM wave. So from the power relations only, we are going to get the expressions of voltage and current relations of AM wave. As we know, power equal to V square by R, R equal to I square into R. By using the two formulas, we can replace PT as Vt square by R. PT as Vt square by R. Carrier power as Vc square by R into 1 plus mu square by 2. If we cancel RR and LHS side and RHS side, we are going to get Vt square equal to Vc square into 1 plus mu square by 2. Vt square equal to Vc square into 1 plus mu square by 2. So, we will get Vt as root over Vc into 1 plus mu square by 2. Vt equal to Vc into root over Vc into 1 plus mu square by 2. This is the voltage relations of AM wave. And coming to the current relations, similarly power replace as I square R. So total power equal to IT square R and PC equal to IC square R into 1 plus mu square by 2. Similarly cancel RR on both sides. We are going to get IT equal to IC into 1 plus root over IC into 1 plus mu square by 2. This IT is the total current after modulation. Total current after modulation, and this IC is the carrier current. Coming to multi-tone modulation. So, multi-tone means M of T contains more than one frequency. M of T contains more than one frequency. So here M of T we can take it as M of T equal to AM1 cos 2 pi FM1T plus AM2 cos 2 pi FM2t. You can consider another term AM3 cos 2 pi FM3 also. That also comes under multitone modulation only. Here FM1 is the one frequency and FM2 is the second frequency. Consider the condition FM2 is greater than FM1. So highest modulating frequency in the information is FM2. FM2 is the higher frequency than FM1. Now, what is the equation of multitone AM wave and what is the power requirement of multitone AM wave? Let us see all these one. So now we know that the AM wave equation, general AM wave equation, AC cos 2 pi FCT is the carrier equation. But carrier amplitude varies in accordance with the message signal. So this is called the carrier modulated signal amplitude. So modulated signal amplitude is AC into 1 plus Ka into M of t. AC into 1 plus Ka into M of t. Now replace M of t as this term. M of t as AM cos 2 pi FMT, AM1 cos 2 pi FM1t plus AM2 cos 2 pi FM2t. Replace the total term and Ka into M1 is called modulation index mu1 and Ka into AM2 is called modulation index mu2. Now the equation of AM wave reduces to AC first term. As we know, the first term as usual carrier term AC cos 2 pi FCT plus second term mu1 AC cos 2 pi FCT multiplied with cos 2 pi FM1t and the third term mu AC cos 2 pi FCT multiplied with cos 2 pi FM2t. So these are the two terms. First term is carrier and the second term cos 2 pi FCT multiplied with cos 2 pi FM1t. As we know, multitone contains the two frequencies 2 pi FM1t and 2 pi FM2t. So we are going to get one more product term mu2 AC cos 2 pi FCT multiplied with cos 2 pi FM2t. Again apply the cos A cos B formula in the second term and the third term also cos A cos B formula. If we apply, then the term simplifies as AC cos 2 pi FCT, that is the carrier term, plus second term mu1 AC by 2 cos 2 pi into FC plus FM1 into T plus mu AC by 2 cos 2 pi into FC minus FM1 into T. Here the cos A cos B is A is 2 pi FCT, B is 2 pi FM1T. So A plus B means cos 2 pi FC plus FM1 into T. A minus B means FC minus FM1 into T. This is the two terms from the second term. And the third term is also we are going to apply cos A cos B. So this will become mu2 AC by 2 A plus B cos 2 pi into FC plus FM1 into T plus mu AC by 2 into cos 2 pi into FC minus FM2 into T. So these are the terms appearing in the multitone AM wave. Carrier term, this term is called AC cos 2 pi FCT is carrier term. Second term is called, we are having here the two upper sideband terms. Upper sideband means more than carrier frequency. More than carrier frequency, we have FC plus FM1 term is there and FC plus FM2 term is there. So these two are the upper sidebands. So we got as upper sideband 1 and this is called upper sideband 2. Similarly, lower sideband terms 2 are there. Lower sideband 1 and lower sideband 2. So totally in multitone AM wave we have these terms. First term is carrier. Second term is upper sideband. Upper sideband 1 and lower sideband 1 magnitudes are mu1 AC by 2. Mu1 AC by 2. Upper sideband 2 and lower sideband 2 term is mu2 AC by 2, mu2 AC by 2. So let us see the power calculations in multi-tone modulation. So this is the spectrum here. You can observe here. M of t contains the more than one frequency. So here in figure F1T, F2T, F3T. Three different frequencies are there. F3 is the highest frequency. Consider F3 as the highest frequency among F1, F2 and F3. And this is the carrier signal, cause signal. So after modulation, we are going to get three upper side bands. First upper side band term is Fc plus F1. This is the upper side band 1. Upper side band 2, Fc plus F2. And upper side band 3, Fc plus F3. So three side bands are there. This is the first side band, Fc plus F1. Second upper side band, Fc plus F2. And third upper side band, Fc plus F3. Similarly, the lower side band terms also three lower side bands because it contains three different frequencies. So lower side band 1 we call it as Fc minus F1. Lower side band 2, Fc minus F2. Lower side band 3, Fc minus F3. So first side band, lower side band Fc minus F1. Second lower side band Fc minus F2. And third side band Fc minus F3. This is the spectrum of multi-tone AM wave. Coming to the bandwidth, what is the bandwidth calculation for multi-tone AM waves? So the spectrum occupies from Fc minus F3 to Fc plus F3. So bandwidth calculation, upper side band minus lower side band. So upper side, it occupies Fc plus F3. It occupies Fc plus F3. And lower side band, it is Fc minus F3. So minus Fc minus F3. So what happens? Fc gets cancelled each other. 2 into F3. So bandwidth calculations in multi-tone modulation is twice into highest modulating frequency we need to consider here. Highest modulating frequency. Suppose F1 1K, F2 2K, F3 3K. For example, so bandwidth occupies, how much bandwidth it is going to occupy means, what is the highest frequency in these three is 3K is the highest bandwidth, highest modulating frequency. So bandwidth is 2F3, that is 2 into 3, that is 6 kHz is the bandwidth of the multi-tone AM wave. So let us see the power calculation. So total power equal to carrier power plus upper side band 1 power plus lower side band 1 power plus upper side band 2 plus lower side band 2. We are considering only two frequencies, FM1 and FM2. Suppose one more FM3 is there, one more upper side band and one more lower side band is also added in the total power. So carrier power, what is carrier power? AC is the peak value, by root 2 is the RMS value, whole square by R. So this term we are going to get AC square by 2R. What is the upper side band 1 power? Upper side band 1 power is, as we know, the peak value is AC mu 1 by 2. Peak value is root 2. Peak value by root 2 is the RMS value divided by R. So this term you are going to get AC square mu 1 square by 8R. AC square mu 1 square by 8R. Then what is lower side band 1 power? Again lower side band is AC mu 1 by 2 root 2 whole square by R. That is AC square mu square by 8R again. Similarly, upper side band 2, we are going to get AC mu 2 by 2 root 2 whole square by R. That is AC square mu 2 square by 8R. Which is same as lower side band 2 also. Lower side band 2 also. In each case, you need to consider only peak value. So RMS value is peak value by root 2, RMS square by R. That is the power calculation. So total power, if we substitute all values, total power equal to first power AC square by R, AC square by 2R. Second term AC square mu 1 square by 8R. plus AC square mu1 square by 8R plus AC square mu2 square by 8R plus AC square mu2 square by 8R. These are the total powers. Carrier power, upper side band 1, lower side band 1, upper side band 2 and lower side band. If we simplify, if we take again AC square by 2R as the common, 1 plus mu1 square by 2 plus mu2 square by 2. You can consider total modulation index mu t as mu1 square plus mu2 square. We can replace this mu1 square plus mu1 square plus mu2 square as the total modulation index. Then total power we are going to get as Pt equal to Pc into 1 plus mu t square by 2. This mu t is called the total modulation index of the multi-tone AM wave. This is the power calculation for multi-tone AM wave. So current relations also multi-tone AM wave Pt equal to Pc into 1 plus mu t square by 2. Here mu t is called total modulation index. Mu t we will call it as root over mu1 square plus mu2 square. Mu1 is the modulation index for FM1, mu t is the modulation index for FM2. First message signal and second message signal. This is for multi-tone AM wave. Similarly, voltage relations also Vt equal to root over Vc into 1 plus mu t square by 2. This is the total modulation index we need to consider in the voltage calculations also. Similarly, IT current relation is root over Ic into 1 plus mu t square by 2. These are the power relations, voltage and current relations in terms of multi-tone AM wave. Multi-tone AM wave. So total modulation index, suppose it contains n frequencies, it equal to mu1 square plus mu2 square plus and so on mu n square. If it contains the n terms. This is about the single tone and multi-tone AM wave power calculations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.